If someone were to toss you a tennis ball, you would catch it without a second thought. If someone were to toss you a bowling ball, you would probably step aside. A small toy fan spins really fast, but you can stop it with your finger. A road roller wheel spins a lot slower, but you are not stopping it anytime soon. These are both examples where a fundamental property of matter comes into action. Let's understand what this property is. From daily experience, we know that moving a feather is a lot easier than moving a brick. We know that handling a dumbbell is a lot harder than handling a chocolate bar. But we don't pay much attention to the other side of this idea. I mean, stuff just stops on its own, right? Like you push a wheel down a pavement, it rolls for a while, slows down on its own, and then stops. So we learn this lesson over and over, that you need to push something to make it go, and if you leave it alone, it will come to a stop eventually. And the thing is, most people would agree with you, and not just average normal people. I mean really smart people like Aristotle, the Greek philosopher. I mean, this guy was Alexander the Great's teacher. He had to be right? Actually, it would take another 2000 years before another really smart guy named Galileo began to ask some uncomfortable questions. Galileo noticed that when you send a ball rolling up an incline, it slows down. And when you send a ball rolling down a hill, it speeds up. Galileo asked, what would happen if the hill or incline didn't slope up or down? A hill that doesn't slope up or down is what we call a plane. Galileo's answer was logical. The ball wouldn't speed up and it wouldn't slow down. It would keep moving at constant speed. Let's look at one of his experiments in more detail. Galileo worked with inclined planes, setting up many experiments. He noticed that when a ball was released on a downslope, its speed increased. When it reached a flat surface, it began moving at constant speed, and when it hit an upslope, it slowed down. He also noticed that the change in speed was positive when the ball was rolling down. In other words, the speed increased, and negative when the ball rolled up, or in other words, the ball slowed down. So what is actually going on here? To understand what really happens with objects at rest and in motion, we need to define something called state. No, not solid, liquid, or gas. To us, state has a different meaning. To us, the state of an object is a set of properties, like the object's mass and the object's speed. If the object is not traveling anywhere, the speed is 0. If the object's distance from you is changing with respect to time, the object is in motion. And a third property, the direction of its motion. But don't we already know all this? I mean, a thing moves because you push it. What's new here? Well, Galileo also discovered something else. If an object is already moving at constant speed, it will keep moving at constant speed forever, unless some kind of external force is opposing this motion. It was this second insight that was denied to Aristotle and to most of us if you think about it. And the reason Aristotle failed to realize what Galileo had was perhaps because he did not consider the effect of friction on the movement of objects. Friction is a force that always opposes motion. If there was no friction, Aristotle's ideas would have been proven wrong a lot sooner. Of course, there was no friction would mean that life itself would not exist, but that's a conversation for another day.
Manorama Horizon. Learning made simple.